Welcome. Let's start with our quick quiz review from last time. Last time was dark matter. So here's your quick quiz question. Be sure to write down that answer so you can take the clicker quiz at the end. Moving right along. Today we are going to be talking about AGN. So what is an AGN? An active galactic nuclei. And we're going to take a historical approach. So that means we're going to talk about it as we learned about it. This comes from section 27.1. So, about 50, 60 years ago, we saw these bright lights in the sky that we called quasars. So quasars are an interesting thing. Quasar is sort of short for quasi-stellar radio source. Alright, so quasi-stellar radio source. They were really, really bright in the radio, right? Radio source. But they were small and compact, and so they looked like a star. A radio star, so to speak. But as we started to look at these things, and here's some pictures of them to the side, just look like pictures of stars, we realized that they were very, very far away. Here's this bottom picture here is what a quasar looks like in the radio. We realized that the closest one of these quasars, closest quasar, was a whopping billion light years away. 1 billion light years away. So this probably is not a star, because if it is so far away but yet bright and looks like a star, it must be much, much brighter than a star. We don't see stars that are a billion light years away. The other thing, if something is so far away, we know that light takes time to travel. We know that it somehow happened a long time ago. We're seeing this from the past. So the other thing we know about quasars is they don't happen now. So they have not occurred in the recent past. So what do I mean by that? Just to break that down just a second. If the closest one that we see is a billion light years away, and light took a billion years to get from that quasar to us, if we don't see any closer than a billion years away, then the most recently a quasar could have lit up, could have put out that light, was a billion years ago. Got it? Okay. So closest quasar, a billion years away, and they seem to be more of them farther away, so it seems to be some event that happened in the past, but not today. Interesting. Okay, let's build on that a little bit. So if it is really that far away, just looks like a bright dot in the sky, it must be incredibly, incredibly bright. So the luminosity, the amount of energy that it puts out, equals about, are you ready for this? 1,000,000,000,000 to 1,000 trillion. I don't even know what the number word is for 1,000 trillion. Quadrillion or something? 1,000 trillion suns. This is much, much brighter than we saw with supernova. Remember supernova, they were like a billion suns? That seemed bright enough, right? Like as bright as the center of a galaxy. Factor that up, 1,000,000,000,000 suns. Okay, this is more than the brightness of a galaxy. Okay, amazing, amazing stuff. So what is this thing? What is this quasar? that shows up in the radio is really, really far away, so it has to be really, really bright. Well, it took us a while as scientists to figure this out, but we eventually figured out, and here moving to the next section here, section 27.2. So moving up in history, we eventually figured out that these bright quasi-stellar radio sources are what we now call AGN. So an AGN is an active galactic nuclei, or nucleus if they have a single one. Nucleus. That means that it's the small, and they are relatively small, and bright, very bright, center of a galaxy. So that was the galactic nucleus, center of a galaxy. Not every galaxy, as we'll find, but some. So just to put that together, quasars then are very bright, very luminous AGN. And here in this picture, you can see some different images of an AGN. The letters are radio, optical, or X-ray. So they have different features. It looks like they have some kind of jet, different brightnesses. So there's a lot to explain our various observations here, trying to figure out what's going on. So let's just talk about that. What do they look like? What is sort of interesting about these guys? So, what do AGN look like? They look different, as I was just showing in that last picture, at different wavelengths. And that's because they produce light all across the spectrum. So they produce all types. I think I'd get better at this pen, but I'm still having trouble. All types of light from the radio, where they were first discovered, quasi-stellar radio sources, from the radio to gamma rays. And we see jets. So sometimes we see jets of radiation at these different wavelengths. So we have a really bright source, plus we have jets in radio, optical, gamma rays, the whole shebang. Okay. We also see gas swirling at high speed around the center. So gas swirls around the center at very high speed. Whoa, what happened? There we go. Up here, around the center at high speeds. So what does that tell us? High speeds, thousands to tens of thousands of kilometers a second. That means there's a lot of energy. There's a lot going on around these things. And you can see from the picture there, we have an artist's interpretation of what this might look like to give you a sense of the swirling gas and the jet and all this going on at once. We also know a little bit about the size of these things. That when we look at them and we see this swirling, we watch the light swirl around, it moves really fast. The light varies very rapidly. Remember we saw this with a pulsar? Those neutron stars that rotated super fast? They pulsed very fast. We see a similar thing here. Because the light varies so rapidly, it must be a small thing. So it must be small, just like that neutron star was small. We see the light vary on the order of a day, not as small as a neutron star where it was per second, but on the order of a day, so this is not a big thing. Maybe about the size of our solar system or so.